There's been a lot of requests for more information on the big Tesla coil, so I'll be showing more of the components and the housing in which the big coil is stored in. Here's the control cabinet, made up of two 19-inch racks bolted together. Houses all the controls and the inductive ballast. There's an oil pump at the bottom, circulates oil for the inductive ballast, which is sitting in a container full of oil, and it is pumped through a heat exchanger going to the outside. Multiple taps for different inductance ratings. Right now it's set at 2.8 millihenries. Some more inductive ballast, relays, resistors, two 450 amp contactors for the main power source to the transformers, various filters, and current transformers for the metering and the scope. Pull-out rack for the low voltage control circuitry, containing all the low voltage power supplies. And the main meter panel. And then the power out goes to the transformers. Two 7200 volt transformers. They're wired in series, so I have 14,000 out. This goes to a horn gap and some filtering, high voltage filtering. Then goes through conduit. High voltage goes into the transition box, which has all the power cables, wiring, and control circuitry going outside underground to the Tesla coil. There's a filter blower on top that blows air through the outside lines to keep moisture and dirt out of them. Here's all the underground PVC pipes, which runs out to the track. To run it on high power, I swap out one of the 7200 volt transformers with this 14,000 volt one, which gives me total power of about 21,000 volts and over 26 foot sparks. This is the building that the coil sets in. It's 9 foot by 8 foot by 20 feet tall, and the doors are 19 feet tall. And now I'll open the doors and roll it on down the tracks. The toroid is 8 foot diameter, made of plywood, styrofoam, and chicken wire. A 10 foot by 2 foot wound coil, open frame made from PVC and plywood. It is wound 9 feet with 6,000 feet of number 14 THHN PVC wiring. .5/8" copper primary. All RF connections made with brass strip. This is the back side of the synchronous rotary. The variac mounted on the back is a feedback device that runs a meter inside the shop. It tells me where about the phase is set. This 5 horsepower motor is on a ball bearing cradle and can move 180 degrees either direction to control the phase and sync operation. This is the wiring from inside the shop. Once again, the rotary, 300 or 3600 RPM 5 horsepower motor, driving a 13-inch G10 disc with steel electrodes. And the motor housing itself is chain driven from a gear motor to control the phase. Two Maxwell capacitors in series. Each one is 0.367 microfarad at 40,000 volts, which I believe comes to like 1.173 microfarads in series at 80,000 volts. Over voltage gap. The rail system